John is the Tisch University professor in the Department of Computer Science at Cornell. He received his bachelor's degree in computer science from Cornell in 1993, and then an SM degree from MIT. Does anyone know what an SM degree is? It's kind of a combination MBA-MS degree. He received that in 1994, and then in 1996 he received the PhD degree from MIT. John's research focuses on issues at the interface of networks and information, with an emphasis on the social and information networks that underpin the web and other online media. His insights were partially responsible for Google's search engine strategy of ranking web pages based on the number of pages that link them. Besides his web expertise, he has collaborated with biologists on problems in protein folding and databasing of biological molecules. He has also worked with behavioral scientists to study the sociology of the web and how it has changed over time. John's work has been supported by an NSF Career Award, an ONR Young Investigator Award, a MacArthur Foundation Fellowship, commonly known as a Genius Award, a Packard Foundation Fellowship, a Sloan Foundation Fellowship, and grants from Google, Yahoo, and the National Science Foundation. John is a member of the National Academy of Sciences, the National Academy of Engineering, and the American Academy of Arts and Sciences. In addition to literally scores of scientific papers, John is the co-author of Networks, Crowds, and Markets, Reasoning About a Highly Connected World, published by the Cambridge University Press in 2010, and Algorithm Design, published by Addison Wesley in 2005. John Kleinberg, what can Facebook, Amazon, and Google teach us about ourselves and society?
All right. Let's see. Is that working? Let's see. All right. Can you all hear me back there? Is that working okay? Sounds good. Okay. Well, thanks very much. Thanks, first of all, for the invitation to come speak here. It's really a great pleasure to be part of this lecture series and the whole set of events going on at Cornell this summer. And thanks very much for the kind introduction. So what I wanted to talk about this evening was issues around this question up there, what we can learn from these new developments taking place on the web, the development of emergence of things like Facebook, like Google, Twitter, things like that. And to talk not just about what they look like now, but maybe also about some of the scientific underpinnings behind them, right? How we can start to reason about some of what takes place on the internet scientifically. And in the process, what we'll see is that this is a science that's really in its very early stages. And like any early science, there's a lot of groping around, there's a lot of wrong directions, a lot of backtracking. And that's sort of the exciting thing about new sciences, right? They're correspondingly more unexplored. They're also, it's a little more wild territory. So I'm not going to propose any definitive answers. I'm actually more going to try to show the process by which one thinks about these kinds of questions. So to think about these questions, we have to start by thinking about where did all these things come from? And they're all built on top of the internet and the web. And so it really harks back to something that happened roughly 20 years ago this year, in the very beginning of the 1990s, the widespread public embrace of the web, which really happened in the first few years of the 1990s. And one thing that's important to appreciate, to put this in context, is the way in which our view of what the internet and the web are has changed, right? When you see some new piece of technology, you apply your own mental insights, your own metaphors to it. And certainly when it began appearing widely in public, 1993, 1994, people spoke about it as kind of a vast universal library of all human knowledge, something you would dip into to extract nuggets of information. And there was sort of this picture, like on the left, that, that the web had really was this enormous virtual library. And that was really an amazing development, and the development of search engines was there to support that. and that was, in a sense, the first 10 years of the web. And you could say that what's happened in the second decade of the web is that this layer of human interaction has been added onto it, so that we go from a picture, a mental model like the one on the left, to the one on the right. since, as all of you know, the experience of being online today is really the experience of being part of a gigantic crowd of people. And when an event happens, not just learning about the event, right, as one would in this sort of information-rich view of the world, but also learning about the experiences and opinions and reactions of millions of people to that event. Right? So it's like standing in a crowd where somehow the thoughts of the crowd are actually being expressed, and you have to piece together some picture from all of those tiny fragmented perspectives. Right? And that's what's challenging when we think about the web. So what's going to be particular to the talk here is that I want to focus on how we go about studying these kinds of phenomena. And in a sense, that starts from the premise that science always advances when you can take something invisible and make it visible, right? And that was true with molecular biology. With increased resolving power, we can see things we didn't see before. It's true with astronomy and astrophysics. When you can resolve things more exactly and more distantly than you could before, you can make progress. And that's what's taking place now when we try to study social interaction and how it takes place online. Right? It was sort of an irony that for much of the latter half of the 20th century, we somehow seem to know more about the genome of yeast or exploding stars in the outer reaches of the galaxy than we knew about how human social groups function. Right? Despite the fact that how human social groups function is really the world that we live in, and all those other things were remote from our experience. But the point is that somehow human social interaction was this particularly fleeting, ephemeral, almost unknowable thing. Right? It went unrecorded, and we were sort of left to guess at how it worked. And that's really what's changing, right? Now when people are interacting publicly online, there are these detailed traces that we can actually try to apply scientific study to, right? So we can take a crowd like that reacting to some event, right, and reacting to it through text, through photos that they take, all of those things, and we can look at what trace that leaves on the internet, right? Take that crowd there, for example, right? Whatever it is that they're all looking at, many of them will have out phones and they'll be taking pictures, or they'll have out cameras, they'll be taking pictures. And those pictures are exactly what would have been taken and then gone and forgotten 20 years ago. Now, if even a small fraction of those people upload their photos online, then we're going to have some kind of a hotspot, right? A hotspot in space right there, that something happened at that point in time and many people took pictures of it. And if we put all those together, we can look at photos across the entire world, right? So imagine you had a big black screen, and every time someone uploaded a photo and they tagged its location, or maybe their phone with its GPS tagged its location, we put a tiny white dot on that black screen. Right? What kind of pattern would we get on that screen? Well, something like this, right? So this is that black screen, and these are photos uploaded to the photo sharing site, Flickr. Okay? You could do the same thing with Facebook photo uploads or any other kind of photo uploading site. Flickr has the nice feature that its data is public by design. There's people who want their pictures to be looked at. And so we can take these, we can take the latitude and longitude, and we can put them there. Right? Now, the point is, this is just dots on a black screen, right? So the fact that you see a map here, if you do, is purely in your own minds, right? It's in you're resolving that just by looking at it. But we certainly see how the dots, right, they hug coastlines. We see actually particular bright points here, right? Bright points there and there and there, and, right, where there are high population centers. Right here we're looking from, in a sense, very far away. And we see other things, right? We see the curves of rivers. We see places where lots of tourists with their high-tech equipment come and upload digital photos as they do things. This region here is strangely black. You can wonder why that is. All these questions, right? And the point is, you see a map, right? And of course, this is not a physical thing. This is really something that talks about how people experience the world, and really people who are on the internet, right? Because we can't look at this map without noticing that certain parts of the world, which are actually highly populous, are quite dark in this picture because the internet, right, those people do not have nearly the level of access to the internet that people in other parts of the world do. So now let's go back to how we analyze this. Because one problem when you go look at this data, I mean, it's interesting to look at this and see what you can visually make out. But if you really want to analyze it, right, there are hundreds of millions of dots there that make up this composite picture. And it is not something where you can just look at the data. You can't say, well, let me just look at it and see what's there. Right? To look at data at this scale, you need to use computer algorithms. And the problem is those computer algorithms only know what you put into them. Right? So they don't have knowledge of the world. They don't know this is the Nile River. They don't know any of that. All they can do is look at patterns and try to see what they can learn from patterns. And so one thing that is sort of an interesting thought exercise is to ask, well, how much can you learn from this kind of raw data? in a way, when we think about this, I'm sort of reminded of a lecture I went to my senior year of college, spring of 1993, just across the parking lot in Bailey Hall. Carl Sagan was talking. And the title of his talk was, "Is There Life on Earth?" Sort of a strange title. And it was actually a reprise of a phrase that Nature had put on its cover earlier that winter when they had published his article, A Search for Life on Earth, from the Galileo spacecraft. The conceit was the following, that the Galileo spacecraft, on its way out to the outer solar system to do one of Carl Sagan's exobiology surveys, right, looking for life on other planets, it did this elaborate slingshot where it kind of went through the inner solar system, picked up speed, and then came rocketing back out to the outer solar system. And in doing so, it actually passed over the Earth. Right? And as it passed over the Earth, it turned its formidable battery of measuring instruments down on the Earth, and it went on. And Carl Sagan's point in this talk was, if we're going to go and try to look for life on the moons of Jupiter, right, at the very least, we ought to be able to detect that there's life on Earth, right? Because if we can't do that, this is all probably going to be a big waste of time. And so he asked, can we do that? And so for the hour of his talk, he asked us to imagine that we're an audience of Martians attending a lecture by him, a Martian scientist, and we're looking at these readings coming off of the planet Earth, and we're supposed to decide, do we think that there is life on Earth? And he talked about things like the oxygen-methane balance and all sorts of other things, and argued that there was this convincing case that something down there was really doing something kind of lifelike, right? So the funny thing is, it was an intriguing lecture. I didn't think about it much for 10 years, but now I actually find myself coming back to it, and I actually find that I tend to think a lot nowadays about Martian scientists. And the reason is not a dangerous sentence to take out of context. I gave a talk in the fall in London where I said that, and someone in the audience, a reporter, tweeted, John Kleinberg says he often thinks about Martian scientists. But in my case, the emissions coming off the Earth are not physical or chemical, they're digital. Right? So assuming you had Martians who could look at this and could, look at this picture back here and, could read ASCII characters or whatever Flickr is encoded in, what would they learn about us, right? What could they figure out from these digital emissions coming off the surface of the Earth? It certainly looks suggestive, right? What could someone with no knowledge about the world, only able to look at patterns and in a very powerful way, right? Because that's how we should think about our computers. No knowledge about the world, but unbelievably powerful at detecting patterns. What would they learn, right? And the point really is that they're trying to learn something about what exists in our human brains, right? And so this issue of looking at maps and trying to infer something psychological instead of physical really dates back to a bunch of literature in social psychology and related areas. So for example, this intriguing quote from Jaudelet and Milgram in the 1970s when they asked people in Paris to build their mental map of Paris. They would give people paper and say, please draw what you think Paris looks like. Right? People had lived there their whole lives, and they compared them. And there were all sorts of things that were actually different from the way it actually was. It said that the way people encode things in their brains may be different from the physical world. And they made this contrast, right? That someone who harbors a mental model of Paris may die, but the city endures. On the other hand, okay, this little melodrama coming up, but the city may vanish through flood or nuclear holocaust, but the maps encoded in human brains are not thereby destroyed. It exists in our minds even independently of this physical existence. And at the time, and Stanley Milgram, he'll show up in the talk later on also, was very creative in trying to extract these questions about what is the experience of living in a giant population. And a lot of his ideas now come back when we look at the internet, precisely because it starts to allow us to ask that question in a more quantitative way. What is the experience of living in a giant population, right, when we look at things like this? So a couple of years ago, a bunch of us at Cornell, myself and Dan Huttenlocher, Dan's student Dave Crandall, my student Lars Backstrom, the four of us decided to try our own life on Earth experiment and to ask how much could you really learn from a picture like this, going only from the patterns, right? You've got where the picture was taken, you've got what was in the picture, you've got what people typed about the picture, right? When you upload to Facebook or Flickr, you can tag your photo, other people can tag the photo. So we have words, we have images, we have locations on a map. And so we imagined the following kind of procedure, which is we took disks that were about 100 kilometers in radius, and we sort of slid them around this black canvas. And we let them come to rest where the dots piled up the most strongly. Okay? So the disks kind of were drawn toward greater concentrations of dots, and when they got to kind of a local accumulation of them, they stopped. Okay? So imagine disks all sliding around like that. And within each one, once we're at a 100-kilometer radius, we hope we're in one of these bright spots. the 100-kilometer disk breaks open, and out come a bunch of 100-meter disks. And they slide around looking for places where the dots accumulate really, really strongly. Right? You would hope that even once you're in Paris, which is a bright spot of dots, there's an even brighter spot of dots maybe at the Eiffel Tower, maybe at other kinds of landmarks and monuments within Paris. Okay? Once we're there, we hope we have a collection of landmarks around the city. What else can we hope to discover? Well, there, you're in a crowd all paying attention to the same thing. What is it that they're paying attention to? We can take the text that people typed in when they tagged their photos, and we can look at which are the words that stand out the most from all that sea of words. Now, this is tricky, because when you're on a trip, even when you're standing right at the base of the Eiffel Tower, the words you tend to type in are trip, vacation, friends, photo, France, right? Relatively few of the words are Eiffel Tower. But one thing we have going for us is that words like vacation and trip, photo, friends, they're kind of spread out around the entire world. Everywhere in the world you look, people are tagging those to their photos. But it's only in Paris, and only at that spot, where you get this really big concentration of a phrase like Eiffel Tower. And so the hope would be that we can look for those kinds of things, look for things that stand out much more than they occur universally around the world. And maybe that is the description of what's going on at that place. Right? Again, something where we're trying to bootstrap this and learn only from the data we're given, nothing else. And finally, we took some very nice techniques that our colleague Noah Snavely had been developing and adapted them some to take a whole bunch of pictures taken all at the same place and try to figure out what is it that everyone is looking at and how do we reconstruct it. Okay? And when we do all this, zooming in on one of these bright spots, let's pick that one right there, we get a map like this. Right? So this map also was made up completely automatically. Right? This map, there's no knowledge of the world built in. We can see how sharp the projector is here. But there's a picture of central London. What's striking is you can see the curve of the Thames. You can actually see every single bridge over the Thames, right? Because every time anyone crossing the Thames decided to stop, take a picture, and upload it, that's a dot on the map. And as long as they sort of stopped at random different places, you're going to have the bridge outlined very clearly. And you have the windy roads. London's not great at having a grid of roads, but you can see roads. You can see where things pile up. And there are these 20 hottest hotspots here, where the dots accumulated the most extremely. And the names that stand out, right, what are the most significant pieces of text that were there, are phrases like Piccadilly Circus, Royal Albert Hall, Buckingham, and so forth. Okay? And finally, we can take the photos and actually see what people were looking at. And just as with the text, even when you're standing in front of Westminster Abbey, right, most of the photos are not of Westminster Abbey. They're of your friend, they're of the taxi, they're of the strange hat on the policeman, they're of all these different things. A few of them are Westminster Abbey, so we have to look at, again, sort of a hot spot among the photos to find that. Okay? So the point is, all of this data is there lurking in the text. And you can do this at many different scales. Right here we zoomed way into London, and we looked at what these dots showed us. You could pull back. You could pull back some large piece of the globe, and you would see a picture like this. Right? So here again, we have zoomed in on the map of Europe. We have the 20 biggest 100-kilometer hotspots that are going on there. And within each one, the densest 100-meter hotspot, so the biggest landmark in each of these. And again, so within Paris, we have this photo of the Eiffel Tower. In Bristol, we have Bath Abbey, and so forth. Right? Each of these is essentially a description of what is it that people are looking at, what is it people are paying attention to when you're in that particular point in latitude and longitude. Right? You can do this in Europe. You can do this in the United States. Europe and the United States look quite different. Right? All the way across the center of the United States, you see these sinewy lines all kind of passing through. And this is, as with the bridges over the Thames, every time you pull the car off the road at the interstate to take a photo of something, that's another dot. And when you put all those together, you've got a map of the interstates. And you can see all the interstates converging on Tulsa, Oklahoma, and Dallas, Fort Worth, and I-80 coming down from Reno to San Francisco. All of those lined up, and all of them with pictures and descriptions. Right? And so the upshot is that in this data, the data is rich enough that, yes, even Martians can build credible tour guides to North America, Europe, and so forth. And it was sort of funny when you think back about the technique we're using, these disks that sort of float out to hover over these landmarks and come to rest. It sort of starts to remind you of the beginning of every alien invasion movie that you've ever seen, the giant disks floating out in the panorama showing them hovering over the Taj Mahal, hovering over the Eiffel Tower. And you think, this is the dumbest we've ever seen. How did they know to hover over the Taj Mahal and the Eiffel Tower? And the funny thing is, it's not as hard as you think. In the end, the aliens can even figure out what we call the places. Right? So this is the point, right? That the meaning emerges from the data. Right? We didn't write a computer algorithm that knew about cities or landmarks or what people talk about, it was all there, right? The meaning was in the text. Right? And that's, I think, one of the important things when we think about studying something like the internet, that in the end, there's so much data there that we're going to make the most progress to the extent that we can extract meaning out of that text. Okay? So what I wanted to do, this in a sense was partly a thought experiment. It's actually obviously quite useful in the sense that we can zoom in on any region at any point in time, right? So that big parade last week, in some city, what was going on there, what were the events that happened, where were people looking, we can find that, right? So these are travel pictures of things that we all intuitively know. But even ad hoc events that come up on the fly, one can use these kinds of techniques. So even this can tell us things that we don't know. But it does have the property that it's about the world we live in. We look at it, we say, yeah, that feels right. What I wanted to do was try to take some of these ideas, now that we know there's a lot of meaning in this kind of data, and apply it to a bunch of much harder questions, or at least questions where we really don't know much about the answers. And that's what I'll call the strange geography of our collective social experience, right? So this gets back to the point that years have gone by and we've learned a lot about the solar system and bacteria and atoms and molecules. And it's been harder to apply that same kind of large data quantitative approach to everyday social experience, right? To the everyday experience of you living your life, interacting with friends, expressing your opinion, agreeing or disagreeing with people. All of those are the things that go unrecorded and therefore hard to measure. And so when we started to see data like this, a group of us at Cornell, particularly Dan Huttenlocher and me in computer science, Michael Macy in sociology, we sat down and we said, with the kind of data that's online available, and Michael, who comes from sociology as a background, was particularly passionate in making this point, we could really start to go back and try to attack some of the really classical hard problems of 20th century sociology, but from a new way, with a new perspective, right? And aided by this gigantic amount of data, right? So questions like, how do your friends' behavior, how do their activities affect what you do, right? How are you influenced by your friends? Or for that matter, why is it that people tend to be similar to their friends at all, right? Why do you tend to have similar interests, beliefs, and opinions to your friends? Which, in its own way, is a challenging problem in sociology, precisely because the cause and effect is so delicate, right? Do you have similar opinions to your friends because they influence you and they convince you of things? Or is it because you seek out people who already agree with you and thereby get less challenged in your own opinions, right? All of these are questions that have been very hard to answer at any large scale, where the kind of data one can find on Facebook, on Twitter, on things like that, let us start to address those kinds of questions. And how does the spread of all this information, as we exchange information with our friends and they tell their friends, how does this snowball into some kind of global cascade, right? When we see a piece of news spread around the world, when we see opinion change on something, right? When we see some culture that has looked static for a very long time abruptly change, how is it that that happens? And how is it that that comes together? Okay, I should stress a few things. The first is, in the next 20, 25 minutes, I'm not going to answer all these questions. These are all questions, these are motivating questions. These are guideposts. These are questions that the social sciences have wrestled with for a long time. And the hope really is that we're adding some new perspective to it, right? I guess I should also add there are a bunch of caveats here, right? The first is, of course, that this is not trying to supplant the traditional ways of doing sociology, right? So sociologists, anthropologists, people doing ethnography have this very deep, very well-developed research methodology where you look at small groups of people, you really come to understand them, you understand why these social connections are there, how this influence happens, and you really develop an understanding at that small scale. In a sense, we're on this different pathway, and we're sort of trying to find this meeting point, right? So we have a very, very large amount of data. We have these algorithms that can pick up many, many very complicated patterns, but it has no understanding of the meaning of what's there, right? And I think a bunch of people in the social sciences initially regarded us with suspicion, and maybe rightly so. And whenever two communities begin to talk to each other, there's always some needing to learn the language of the other ones. And so we would show up to their meetings and their conferences and their workshops, and we'd say, we have all this data, we have just so much more data than you do, and we will bury you, right? And for some reason, they didn't seem to, like that pitch. And gradually, in fact, that wasn't quite what we meant, right? What we really meant was, this is a new way of looking at problems, and that's the sense in which we're on one track. We have massive data, but algorithms that can't possibly, right? When you look at 500 million people all interacting online, you can't possibly know what each of them is really thinking, why they became friends with that person, why they stopped being friends with that person. All you can do is look for patterns. On the other hand, you can discover things that are there. They're genuine, but they're so subtle, they just could not possibly be seen at the level of 50 or 100 people. You could study those 50 or 100 people all you want. It's just too small a scale to see this kind of macro pattern. And so I think really what one should think of as these are two lines of research looking for a meeting point, right? Looking for ways to apply the techniques of both to try to arrive at some synthesis, some new perspective on these things. And of course, there are other caveats. This is about the data we can get online, right? There's the issue of how much do our offline lives resemble our online lives? Obviously, those two things are coming closer and closer together as we increasingly interact with people online. But the kind of constraints imposed by the online medium is, of course, another thing one has to keep in mind. And finally, of course, I'm phrasing a lot of this in terms of understanding, but as a computer scientist, there's always a feedback loop between the understanding and the next phase of design. Right? We want to understand these systems better so that in the next generation of these tools, these techniques, we can design them better. Okay, so back to these questions with all those caveats out of the way. And they're all important things to think about. They really sort of frame some of the questions we're going to see. All of these questions, I should say, involve social networks. Right? And so let me step back and draw a picture of a social network. In the same way that we put dots on a map and thereby drew a map of the geographic space that we live in, you can also put dots on a blank screen and draw a map of the social space that we live in. So here's an example of that. I think these lines show up. Hopefully you can see these if you look. This is, now some of you who are under a certain age may have mapped your own social lives this way and be very familiar with images like this. Others of you who are newer to this kind of technology, this may be less familiar. This actually is an engineer at Facebook who generously contributed to his coworkers, Cameron Marlowe and et al., his social circle on Facebook, right? Roughly 100 to 200 people. His friend connections to all of them, these are his friends, and the friend connections among his friends. Right? Now, the funny thing is, unlike the map of the Eastern Hemisphere that I put up, and we all look at it and we go, yeah, that makes sense. I recognize that. The funny thing is, when you're presented with a map, even of your own social circle, you may not recognize it at first. Right? Somehow the visual representation of it is alien to us. We have our own complicated mental accounting of, this is the friend I talked to about this. These people know each other because we all went to high school together. These are my coworkers, right? This person I wouldn't tell this kind of secret. We have that mental accounting. But we don't have as much practice looking at it as an object, as a map, right? And that's no surprise, right? We've been learning how to read maps of the physical world since we were 5 years old, right? We've had a lot of practice reading maps. We have almost no practice reading these kinds of maps. And so it is useful to kind of step back and ask, so what do you learn from a map like this? Right? So here's the center of the network. This person, this is all their friends. And you do start noticing things, right? So there's a big cloud of people all connected here. Right? So these people all know each other. This is sort of one of their social circles. And here I don't mean social circle as a term of art, simply, you know, a group, you know them, they all know each other. This is another set of people who all know each other and all know him. But there are almost no connections between the two. Right? So we could imagine that maybe one of these is their coworkers, one of these is their friends from college who still are all friends on Facebook, and there may be no reason why there's any overlap between these. There are other interesting people here, right? Like this person who they're friends with radiates out a lot. They know a lot of their friends, right? So these people have a lot of mutual friends, and their mutual friends reside in different places, right? So this person, right, has friends here, here, over here, in different of their social circles, right? So this could potentially be a spouse, a sibling, a significant other of some sort, because they seem to have been through many different social worlds together, right? So as you look at this, you start to map out the terrain, but it takes some practice, right? These are not things we look at naturally, this social network, right? Dots for people connected by lines for friendship, okay? Now, that's the picture of all the friends. Now, as you know on Facebook, you accumulate friends, and you know some of them better than others. Could we guess which are the ones, of these social circles, you might guess one of these is their current social circle, and one of these might have atrophied, right? One of these might be old friends from college. They're still good friends with them, but they just don't interact with them very much. Could we tell which is which? Well, again, we have this unlimited ability to look at patterns in the data. What if we, instead of just the friends, what if we looked at all the people they've actually communicated with in the past month, right? Say at least once, at least twice, right? And only keep those connections. Right? Then the picture actually, is it frozen? There we go. The picture thins out a lot. Right? Remember those social circles, right? This was very densely connected. That was. one of them kind of almost vanishes. Right? So that's a group of people, they're all friends, but they don't talk much during a month, whereas these people are all talking a lot during a month, right? So, right, this could be, for example, their circle of coworkers, and constantly they're talking to them, whereas these are people, they're still friends with them, but that's thinned out a lot. That person with their significant, that hub of connections, that person is still very involved in, again, in lots of parts of their life, right? More evidence that that's some kind of significant person in their life. Okay, so this is a map of one person's social circle, right? So this is the analog of zooming all the way into central London and looking at, 2-block radius around Westminster Abbey. It's complicated, but we can eventually make sense of it. Now, it would be nice if I could pull back, right, from this to some kind of global map, right? What does the eastern hemisphere of the world's social network look like? And unfortunately, I can't do that, because there literally is no good way to draw that in a way that would be at all comprehensible. So once we step back beyond one person's social circle, we're going to need to use other kinds of tools, mathematical tools, to even talk about the map of what's there. We can't just draw it, right? And the reason is because of something that people call the small world phenomenon, which is that if I were to zoom out even a couple steps from this engineer at Facebook, right? So not just their friends, but their friends of friends, and the friends of their friends of their friends, and maybe one level out beyond that, I've brought in some very large fraction of the entire world. Right? And it's sort of easy to see why, right? I drew this with my own example. You can think about examples from your own life. If I think about even just people I've worked with, so forget old friends from high school when I was growing up, and so forth. Let's just picture people I've actually done joint scientific research with. So one, for example, is Duncan Watts, a Cornell PhD student, now at Columbia and Yahoo Research. Duncan I've worked with. We have a number of shared friends in common, not drawn here. Duncan grew up in Australia and actually was in the Royal Australian Navy and has a whole bunch of friends from the Royal Australian Navy who I've never met and may never meet. My former PhD student, Amit Kumar, who was from India, now teaches in the IIT system, I've never met his parents in India, for example. But if I think about their social circles, very, very remote from mine at that point, right? So even 3 steps out, through my former student, his parents, their old friends from childhood, you're talking about people very far around the world who speak different languages from you, have essentially really no shared experience with you. And that's only 3 steps out. Right? Not to speak of the worlds you bridge between Duncan's friends in the Royal Australian Navy, Amit's parents and their friends. And of course, it would be somewhat solipsistic of me to even think that I am the shortest route between Amit's parents and Duncan's friends from the Royal Australian Navy. Right? There could easily be some other way that they're connected that I don't even know about. So all of these are the reasons why I'm not going to be able to draw you a map of what the world's social network looks like. It's a real thing. It really exists. It's just we're not very good at thinking about it or visualizing it, and for fundamental reasons, right? For the reasons of this small world nature. So we have to probe it indirectly. We have to think about it in other ways. And it's in this context, actually, that we get to one of the famous experiments from social psychology of the last 50 years, an experiment a lot of you have heard of through its pop cultural resonance, no doubt, which is the 6 degrees of separation experiment. Right? This idea that as we expand out from this engineer at Facebook, right, to his friends, friends of friends, friends of friends, we've pulled in much of the world. Right? That's this idea that we're all a small number of degrees of separation, right? Right? Me and almost anyone in the world, there's a small number of links, social links, from me to a friend of a friend to a friend of theirs, and on to that person. Okay? So Stanley Milgram, we saw earlier, asking people to write down their mental maps of Paris. He was fond of these experiments that took some kind of intuitive, hard to quantify idea and tried to make it into a more concrete scientific experiment. And that's what he did with the 6 degrees. He said, well, let's see if this 6 degrees thing is really true. This was in the 1960s. And people's intuition about that was not very good at that point, right? This idea that we all live in a connected world, which is now such a commonplace thing for us to talk about, that really wasn't so prominent at the time. And so even when he asked his colleagues, professional sociologists, how connected do you think we are, guesses varied all over the place. So he made up an experiment, and the experiment worked like this, and some of you may have heard this experiment. He picked a friend of his who lived in a suburb of Boston, Sharon, Massachusetts. That's the target person. We're going to try to build connections to them. Right? So that'd be the analog of maybe we would pick one of Duncan's friends in the Royal Australian Navy and try to all get messages to that person using our social networks. He then picked people far away, right? People out here like Amit's parents, and sent them letters. Right? So he did it with Boston and Nebraska, because as he said in his paper in the 1960s, Nebraska seemed sort of far enough out there that it was a fair test of getting to Boston, and sent them all letters, 200 people in Nebraska, and said, I'm running this experiment. I want to find out if we're all connected by short paths through society. He found a way to explain this in a way that resonated with people. And so what I want you to do is get this letter to this person who lives in Sharon, Massachusetts. Here's their name. They're a stockbroker who works in Boston. Here's the firm they work at. Here's their wife's name. Here's where they went to college. They were in the military. Lots of facts about them that you can use. But you can't just mail them the letter. That'd be too easy. Instead, you have to mail it to someone you know on a first-name basis with these instructions to try to get it to them as fast as possible. Right? So he can't draw the social network. And in the 1960s, he can't even collect data in any meaningful way on the social network. Right? Nowadays, we could look at the structure of Facebook and try doing something. This is Stanley Milgram using pen and paper and a budget of $680. Right? He's using letters through the mail to try to probe the social network, the way you might try to probe a complicated material using some kind of measuring device. Okay, so the letters all went out. Some people threw them in the garbage, of course, but actually participation was quite high. Roughly a third of the letters got where they were going, to this target. Right? They zeroed in from all over the country, or at least from Nebraska, fanned out and came back in. And the median number of steps was 6, a number that, thanks to the playwright John Guare, entered pop culture as the 6 Degrees of Separation when he wrote a play of that title in 1990. Okay, and what's interesting is that this number, there were lots of intricacies with the experiment, and it's in fact been relatively hard to replicate this experiment. But in some sense, the number has been quite robust. Right? This is Milgram's hand-drawn histogram from his original paper showing the 64 chains that made it to the stockbroker and how many took each number of steps. Right? Here we see the median at 6 steps. 40 years later, and several billion dollars of capital expenditure later, Microsoft and other companies built global instant messaging networks. And if you looked at one of those, as you could look at Facebook, you could just compute that number by brute force. Don't ask anybody anything. Just look at who has who in their contact list and try to find the paths yourself using a computer. And that number 6 was still there. Right? The median of 6, right? Work of Yuri Leskovich and Eric Horvitz. Okay, so this number 6, it's there. We have these short paths. There's something funny about the experiment, though. And when I came back to this, actually following up on some work that my colleagues Steve Strogatz and Duncan Watts did, some very creative experiments, very creative work, computational experiments and theory building at the end of the 1990s, which really brought the small world phenomenon back into people's attention. When I looked at their work, the question that jumped out at me was the following. Okay, these experiments established that the short paths are there, and we can take giant networks and discover that the short paths are there. But Stanley Milgram was asking people to do something much harder. Right? He had set them a much harder task of necessity. Right? Because if you had really wanted to find the shortest way to get to this person, the instructions I suppose you should have sent the people in Nebraska was, we want to find a short way to get to this person in Sharon, Massachusetts. Send this letter to all of your friends. Tell them to send it to all of their friends, and so forth, until one of them actually pops out the other end at this person. And for reasons that you can reflect on, this was not a feasible experiment to do, right? That becomes a gigantic chain letter that runs afoul of all sorts of pragmatic considerations as well as US postal law. And so instead, he asks people to do the much more cognitively challenging task of tunneling their way through the social network. Pick one person. Make your best guess. Right? You have to reach an amateur rock musician in Portland or Oregon, right? And you think to yourself, all right, I know someone who lives in Seattle who's sort of involved with the music scene. I'll send it to them. And they'll probably know some kind of music person in Portland, and hopefully they'll get there in a few steps, right? You have to find a veterinarian who works in the Norwegian army. Okay, I know someone who lives in Norway. Hopefully Norwegians, they know each other. I'll send it there. All these things. You have to actually map out your social network. It was actually, in that sense, a very creative experiment. And as a computer scientist, I almost thought of it as he had almost sort of asked people to perform what was, in a sense, an algorithm, right? Finding a shortest path without a map. And so that was the question I thought was most intriguing about this, right? Why should complete strangers be able to find these short paths? So another hand-drawn picture of Stanley Milgram's from his paper, right? So starting out in Nebraska and zeroing in on this target, right? Shrinking your distance to the target at each step of the way. There's something about the structure of the network that makes that possible. And it's not just shortness of paths. Right? Because after all, if we were all, say, on a big social networking site on Facebook, but we weren't allowed to use our real names, right? We were only allowed to use 9-digit pseudonyms. And I came to you and I said, please get this to user ID number 285-204-482. You'd sort of be stumped, right? You don't know a lot about 285, 204, 482. You know, what are their hobbies? Where do they live? Stuff like that. So sure, the short path might be there, but you have absolutely no chance in some very real sense of finding it. But that's not what happened here. People really did funnel their way in toward the target. And it clearly had to do with the fact that as you zeroed in on someone, as you zeroed in on where they lived geographically, as you zeroed in on what occupation they had, right? So they're a stockbroker. Let's send it to someone who works in the financial services industry. The social network kind of zeroes in with you, right? Things get more densely connected as you get into Boston. People in Boston know each other, right? As you get into suburbs of Boston, those people know each other, and so forth. So it's something about the way our social networks span both space and social structure that makes this possible, right? This kind of things get more densely connected as you move in. And so what this turned out to tell us, and there's a whole bunch of mathematical modeling that goes into this, is that we really have to combine some of our intuitions about geography and other things and our intuitions about networks and social connections and think about how the network is actually embedded in geography. Because clearly, we can orient ourselves socially in large part because how the network is organized in space is somewhat predictable. Right? So here's an example of another friend mapping application on Facebook, something that takes your friends and where they live and puts it on a Google Maps picture, right? So this is this person's friend. You can sort of guess where they live, right? Not that hard, right? And that's sort of the point, right? Your friends tend to be clustered close to you geographically. They're also clustered close to you in lots of other ways. Let me focus on geography. But they're also spread out somewhat, right? And that's crucial. Because if you think about it, what's going on here is that if I tell you you have to get this letter to a faraway target, you sort of need two things. One is you need some social links that span very long distances, right? So I have to get it to the amateur rock musician in Portland, Oregon. I'd better know someone in the Northwest if I'm going to get there in one step. So I need a few very long links. But if it was all long links, then it would have been useless to get to Seattle or Portland, because you get there and everyone has all these long links and no one knows each other within their own community. So once you get there, you need the local connections within a community. So in some sense, in order for the Milgram experiment to have succeeded, you need social connections that span all these different levels of space, right? The very far-flung ones, the medium ones, and the very close-in ones. And if you're missing any of those, then somehow the social structure is deficient in a certain way that's going to keep this from happening. It's going to keep us from being able to find each other. Okay? And I think this is my one, if this counts as a math expression in the talk. It turns out if you work out a simple model of how your connections should be spread out to make search as good as possible, then if you think about what fraction of your friends should be at some distance d from you, then search, at least in a mathematical model, is fastest if that fraction grows like 1 over the distance. Okay? So the fraction of friends at distance d from you should be like 1 over that distance if search is going to work as fast as possible. If your connections are more far-flung than that, you can take big strides, but you can't do that fine-grained navigation at the end to really get to the person within their own community. If your connections are too close in compared to that, you can only take these short little hops across the country. It takes you many steps to get there. Okay? So in a way, the success of the Milgram experiment, right, if one builds models on top of it, starting with some models that Steve and Duncan built, and then models that you put on top of those, you can actually start to make guesses about how our connections are laid out in space. Right? Things that you can guess indirectly from the fact that this experiment worked at all. And when you sort of try to think about what is the broader message here, you can draw sort of cartoon pictures of what does it mean for your connections to span space this way. But it's sort of hard to compete with a picture that, of Saul Steinberg's that appeared on the cover of the New Yorker 35 years ago. Saul Steinberg's view of New York from 9th Avenue. Right? Many of you have seen this, or the many T-shirts that replicate this from your own locale, including Ithaca. Right? He was trying to make a point about how when you think about where you live, right, you pay a lot of attention to the street corner you live on, the pizza place here, and that place you like to get bagels and so forth, and then 1 block away, and of course, you know, the western edge of Manhattan, there's the Hudson River, New Jersey's out there somewhere, the rest of the country, Pacific, these 3 bumps on the horizon, China, Japan, Russia. All of them taking up roughly the same amount of mental real estate. And in some sense, that is the structure you need if the 6 degrees is going to work. Because if I'm going to get from all the way over here into here, I'm going to need to take giant leaps. But once I get here, I need to actually find the person on the very street corner where they live. Right? And so I need links at all these different scales of distances, right? These powers of 10 as they move out. I need my links balanced across all of them. In a way, it's not that different, getting the message there, from how something like the US postal system delivers mail, right? If you want to get mail to me in my office, then you put on the envelope John Kleinberg, Upson Hall, Cornell University, Ithaca, New York, US, right? And the postal system, if you mail this from somewhere halfway around the world, reads that off in reverse order. United States, New York, Ithaca, Cornell, Upson Hall, my office, right? Me, 6 degrees, right? The point is that think of the enormous central planning and capital expenditure that it takes to maintain the US postal system, right? That's a design system. That's something that was built to have that structure, to get everything there in a small number of steps. Whereas in the social network, when Stanley Milgram dropped letters into it and watched them pop out the other side, the structure had arisen all by itself. Right? We weren't trying to design a big message passing system. It just sort of happened. And the links configured in that way. So there was an interesting thing that happened when I worked on this. This was in 1998. Steve and Duncan wrote their paper. 2000, I wrote this paper that followed up on it and proposed how this search could have worked. And a natural question was, you know, so this prediction, the right distribution of links should be like 1 over the distance, right? People ask, so is that true or not, right? Now, of course, when I wrote the paper, I tried to be careful. You know, I said, look, this is an extremely simple model, right? The model wasn't of really, you know, the United States and our friends. It was of an idealized plane with points in it and with links between them. And I tried to sort of say the things you say when you have a very clean mathematical model, that it doesn't really matter if this is really true about the real world. The point is more to establish a model that gets us thinking about this question, and we sort of see qualitatively why search happens and all those things. Still, I somehow did know I was sort of on the hook for this actual prediction, right? It made this very specific prediction about how social links are organized, and the question was, is it true or is it not true? On the other hand, so this was the year 2000. We had the web, but it was the web of information. It was the web of knowledge and so forth. It was not really yet a web of people very much. And so I thought, even if this is a rather specific prediction, who knows when this is ever going to get tested, right? I mean, think about what it would take to test the question of how our friends are really all distributed across geography, right? I reasoned that somehow you would have to create a website where you could convince hundreds of millions of people to all sign up, say where they lived, and say who their friends were, right? When's that ever going to happen? And of course, that happened much, much faster than any of us imagined. And the point was, actually the first group to sort of realize that the data was suddenly, abruptly there to actually look at this was actually a group involving a Cornell undergrad I had worked with, David Libin-Nowell, and some colleagues of mine at IBM, Prabhakar Raghavan, Ravi Kumar, Andrew Tompkins. They discovered that the blogging site LiveJournal in 2004 had begun to have friend links and zip codes, right? This was the beginning of Web 2.0. And so they said, let's actually do this test, right? Let's see whether, you know, friend distributions are actually laid out the way they are in this cartoon, the way you would need for the Milgram experiment. And in a way, when I saw their paper, I was reminded of another talk I went to a long time ago at Cornell. Actually, my first year as a faculty member, I think, by the great Cornell protein chemist Harold Chiraga. And he was trying to test something about the protein ribonuclease. I don't even exactly recall what he was testing at this point, but he had needed a protein where he wanted to test something about hydrogen bonding in a protein. He needed something where there was a particular kind of amino acid and an equal number of bases this way and that way was the same thing, and they would link to each other. And he discovered to his amazement that ribonuclease, one of the easiest proteins to synthesize and work with, had all those properties. And he said it was as though the Almighty had made ribonuclease just for this experiment, right? And so I was somehow reminded that, you know, it'd be a bit of a stretch to say that the Almighty had created LiveJournal to be able to run the experiment, but it had minimally everything we needed, right? We had the zip codes, we had the friends, and so forth. And the surprise was, and this was replicated by my former student Lars Backstrom and some other people on the enormously larger Facebook data in 2010, a very, very close fit to this 1 over distance model. One has to correct for many things that I'm not going to be able to go into, because the population density of the world, right, the world overall, certainly the world of Facebook users, is very non-uniform. And that non-uniformity needs some corrections, but you can sort of preserve the theory through all of that. It makes the same fundamental prediction. Very, very close fit to that, to that model. For those of you, I can utter a second formula here, but on Facebook, for example, the analogous thing is roughly 1 over distance to the 0.95 power, right? So not 1.0, 0.95. But it was sort of striking, surprising to me, to see somehow this experiment begun with the Milgram experiment come full circle, right? Where Stanley Milgram in the 1960s makes up this very creative experiment, runs it using pencil, paper, and the US postal system. A whole bunch of mathematical models get built, starting with the work of Duncan and Steve, continuing on through a bunch of us trying to build models of how this was happening. Finally, 40 years later, we get this massive amount of data, and you see that actually the predictions of some of the models turn out to be right. And what's sort of strange here is that, in a sense, it kind of helps resolve one question: how are social connections distributed across space and other forms of social structure? It opens a whole bunch of new questions. In particular, why do real social networks have this particular geographic pattern, right? Because whatever it is we're trying to do in our everyday social lives or online or any of these things, right, however it is that we're trying to form these connections, we're not trying to run copies of the Milgram experiment, right? We're not all sitting here saying, I'm going to form my friendships strategically so that messages flow through the network as efficiently as possible. That thought does not cross our minds. Maybe only a few of us, but by and large, we don't tend to think that way. We're doing all sorts of other things. We're trying to find a subletter for our apartment. We're trying to find a summer internship. We're trying to decide if we should move to a new city. We're trying to reconnect with an old friend from high school. We're doing all sorts of things that involve social transactions. We're not explicitly engineering how our links fall, but they all fall in kind of the right way. There's some kind of organic process that's causing that to happen, and really people have very little idea what that is, right? So that's really a wide open question. It's sort of intriguing in that it's hard for me to think of hypotheses about how it's happening that seem right, or in the words of a famous physicist, to even think of hypotheses that seem wrong, right? It's just hard to think of guesses as to how that's happening. And one thing I like about it as an open question is it's an open question one can think about with very little sort of prerequisite or starting point. That is the question, right? Describe a plausible way that seems realistic, that seems how human beings actually interact, that produces a pattern of links that spans geography or any other kind of social structure that you want in this optimal way, right? How does it happen organically? Because however it's happening, it's clearly happening in this organic way. Okay, so I want to, this gives sort of an example of how one takes some of this large amount of data, goes back to old experiments from the social sciences and tries to connect these things, tries to learn new things about how the social world is organized, how the online world is organized, and where those two things meet. I want to sort of make a few reflections on things and then wrap up. The first of these is that there are really many questions that go on when you look at social networks, right? This has been one that kind of unifies a bunch of themes, that unifies how our networks span different parts of the world, how they're tightly clustered into different places. But there are many others that are very, very intriguing and the subject of a lot of active research, right? In particular, our links don't just go into different social circles, but they can be stronger or weaker, right? Just as we saw that this Facebook engineers two big friend circles, one thinned out and the other didn't, different of our links can be more or less active, right? What roles do those play, and how can we see that manifesting itself online? Similarly, links can also be positive or negative, right? There's a tendency when you work on social networks to always talk about links to your friends, right? And the online world has picked that up, right? So links online always go to your friends, your fans, your followers. It's this very positive view of the world. But there are people we don't get along with, right? And those are social connections also. And so there is rivalry, antagonism, disagreement. And we see that particularly online, right? And so part of the question here is, in the offline world, how do positive and negative links interact? In the online world, to ask whether some of the tools that we're building, are they in fact contributing to polarization? Are there other tools we could build that might dampen polarization? So many, many questions here. I want to jump to a few other reflections and then wrap up. So 2 points. First is about prediction, and the second is about personalization. Prediction. So we're building models, right? And we're building more and more refined models. We have more and more accurate data. And if you're not careful, you can begin to develop this hubristic sense that we might be able to, in a sense, eventually be able to predict the future in some sense, right? We know a lot about what people are doing. If we could just somehow extrapolate the recent past just a little bit, we might be able to actually predict things, right, with more and more accurate models. After all, in the geographic world, we're getting better at predicting the weather. Is there an analog of that in this online world? right? So, I mean, a particularly concrete version of that question, like, what do you mean by predicting things? Let's talk about something that many industries would love to be able to do, which is predicting hits, right? Predicting runaway successes that no one saw coming, right? If I had enough data, would I be able to do that? And actually, to motivate that question and to motivate some very creative work of Matt Sulganic, Peter Dodds, and Duncan Watts, let me do one more picture from the UK, not from London. Anyone recognize this picture? It's conceivable. Some of you have been there. This is the back room at the cafe in Edinburgh, where if you go in, they tell you that somewhere in this back room with a view of Edinburgh Castle, J.K. Rowling sat and hand-wrote the first manuscript of Harry Potter and the Sorcerer's Stone, right? A manuscript that had a very, very hard time being published, and in a sense, maybe almost was never published at all. And the question is, could you somehow have seen coming, if you really knew enough about the social world, all the interactions, all the connections, could you have seen the enormous success of that book series coming? Or even, does it even make sense to talk about seeing it coming? If you could roll history back 20 years to that back room in that cafe in Edinburgh and run it forward again, would the Harry Potter series again become this runaway global phenomenon, selling 500 million copies, becoming this object of intense global affection? Or would it have failed to get published at all? And would some other deserving work of children's literature that in our world never got published, in this parallel universe become a runaway success? It's an intriguing thought experiment. For obvious reasons, it's not one we can actually run in the real world. We can't roll back time like that. But online, you sort of can. And this brings me to the intriguing experiment that Matt, Peter, and Duncan did online. So what they did was they're motivated by that question. Is there something inherently unpredictable about hits like this? And so what they did was they created a music download site. It was an artificial music download site designed purely for this experiment. But it had about 40 songs on it by actual bands trying to break through, real people playing real music, but not anyone you would have ever heard of by listening, online, radio, or whatever. Okay, these were obscure bands. And people were invited to go there. They didn't realize it was an experiment. Listen to the music, preview songs, and the ones they liked, they could download. Okay. And as with many of these sites, there was a most downloaded list, right? Sort of a bestseller list, a leaderboard in a sense, right? That said which songs are the most downloaded. And you might not be surprised to hear that success tends to feed on itself. So the songs that were high up on the leaderboard, where you could see them, new visitors would come to the site, about 14,000 visitors in all. They'd listen to the songs, they'd try out the ones at the top, and those would get more downloaded, which would only amplify their lead over the other ones. Okay, that's a kind of natural rich get richer social feedback mechanism. It's something we see all around us. If that had been the only point, it would have been a nice experiment, but it would have been confirming things we kind of believe. But that wasn't really the point. The point, also unbeknownst to the users of the site, was that when they actually went to the site, they were deposited into one of 8 parallel universes. The site actually was running 8 different copies independently. And when you went there the first time, it rolled a die or whatever, and it said, you're in universe 3. And it stored a cookie in your browser that said, this person's in universe 3. So whenever you came back, you saw universe 3. Right? You told a friend about it. They went there. They were in universe 5, right? Randomly. And, okay. They didn't do any manipulation. These universes were all really identical starting conditions, but they all evolved independently. They all followed their own accidental trajectories where, for some reason, in universe 6, the first 10 people to sign on all just happened to like this particular style of music, and so it jumped up on the leaderboard. And then other people downloaded it. And it just kept climbing, and eventually nothing could bring it back. It wasn't actually a very good song. It was not, one of the better songs on the site. You just got this lead, and there was no pulling it back, right, once the ball was rolling. And in universe 2, it was getting hammered, right? No one was listening to the song. No one was downloading it, right? It really was taking a bunch of people who were roughly indistinguishable from each other and just letting history run its course 8 different ways, right? And they ran a 9th universe, the control universe, where you didn't see a leaderboard. You were actually on your own. It was actually about what music you actually liked the most. And from that, they could get a sense of what songs a random sample of people actually liked the best. And they discovered that the worst songs never ended up at the top in the other 8 universes, right? So eventually, if it's truly bad, it's just, And the best songs never end up at the very bottom. But most other possibilities and permutations could happen. Right? And so they drew from this a conclusion, and they actually stated quite strongly, and as time has gone on, Duncan has actually just recently written a book that tries to make this point very strongly, that there may be something about social outcomes that are inherently unpredictable. Right? Accidental things that happen early on in the process set things on a course that it can't be pulled back from. Okay? And so, and in particular, the point Duncan makes in his new book is that it therefore becomes dangerous to look at successes and say, here's why that happened, right? So, for example, the success of Facebook, right? People ask, you know, do you think Facebook was so successful because it started at Harvard at just the right time? Maybe it was the exclusivity of Harvard that kind of gave it this luster that allowed it to break into the crowded market at the time of Friendster and Spoke and Tribe and all those things that became flaming wrecks on the social networking highway. And Facebook kept going, right? And maybe it was that exclusivity. And, you know, and you hear people talk about, you know, when I create my social networking site, you know, I'm going to have it be exclusive because that's what Facebook did and that's what works. And that may all be true. But the worry is that that's a retrofitted explanation. And that if you went back to February of 2004 and ran history forward again, Facebook wouldn't have succeeded at all, right? In some other universe, maybe all these accidental things wouldn't have gone in its favor. And therefore, the exclusivity of Harvard, while it may have played a role, it's not somehow decisive, right? And so extrapolating from a small number of successes, which we're very prone to do, is in the end can be a dangerous activity. Now, again, these are all open questions. People argue different sides of them. But it's sort of an intriguing thing to think about and something one can now begin experimenting with. OK, my last point, and then I'll wrap up, is moving from prediction to the personal. And what's funny is that, you know, we talk about collecting massive data sets, right? Massive data sets about the entire world and the social connections within them. It's not just the world as a whole where we collect these massive things. It's also each of us individually, right? There's actually massive data about you, right? If you keep your email online, right, your inbox, right? Your inbox may be several gigabytes worth of text and photos and all sorts of other things, right? Or, you know, your complete trace of Facebook activity. This is a level of data that 30 years ago you would have hired a professional to curate for you. And now you're sort of thrown into the deep end on your own to deal with this massive amount of data. And so we're collecting enormous amounts about each of us. And so one starts to be able to see the possibility of building models about people individually, right? Not just about populations as a whole. And there are certain things looming on the horizon that are kind of striking, intriguing, maybe possibly troubling, right? The prospect of software that in the end understands your behavior better than you do, right? That knows things about you because it's observed them statistically, right? Regularities and patterns, right? When do you last eat before you go to bed? How does your efficiency tend to decline late at night? What are the 3 things you do first when you wake up? There are certain regularities in your behavior that you may not consciously internalize, but some software watching you, right? Your Gmail inbox knows that. Your Facebook account knows that, right? These kinds of things have very, very detailed pictures of your behavior. They just often don't share them with you, right? I was sort of struck by this actually reading a paper a few years ago. This was a paper of Laszlo Barabási's, where he was building some models and making a prediction about human response times. And he included in it this intriguing prediction, not about global social networks, but about individuals. The speed at which people respond to email. And the question was, what fraction of your email messages do you answer on the day of arrival, 1 day later, 2 days later, 3 days later, 60 days later? It's a question I find hard to ask without feeling some pangs of guilt on the part. Yeah. But, right, things pile up. You deal with them over time. But what fraction do you do on each day, right, each day of lateness? And there's some curve that decays with that. And again, there was a mathematical prediction, maybe my last formula of the night. The fraction that you deal with d days after arrival, his prediction from his model was it should be roughly like 1 over d to the 1.5 power, yet another d to some power, right? And that's fine. He had reasons for it and so forth. But I thought it was intriguing that this was a prediction I could test out, because I had 10 years of saved email lying around. So let's just take it, and let's take each message I replied to. I was doing this, by the way, when I should have been answering someone's email. But you go back and you say, what was this an answer to? And how many days was that? And let's plot a curve. Okay? So I did that. I plotted a curve. And this blue line is his theoretical prediction. This red line is me answering my email and the curve that you get from my actual email. This is transformed axes. This is about 60 days out, right here where they begin to diverge. So from 1 day through 60 days, the prediction was essentially perfect. And I mean really perfect. I mean, first of all, there's a strange thing that looking at my saved email when I replied to it, you sort of were seeing a curve of a smoothness that seemed to have arisen from some kind of physical experiment. I mean, you know, it just went down just so smoothly. Yet it was my behavior, which is anything other than smooth and precise. It's like chaotic. It's like, do I feel like going to bed at 1:30 or should I answer these 2 more messages? There's nothing regular about it, but it just looks so regular here, and it's exactly on the line that he had there. There's something striking about it, and striking in a number of ways, right? One, about the prospect of all of these statistical regularities accessible to our systems, and maybe really having more structure than we ever imagined. And of course, also just the sort of visceral sense of reading a paper that makes a prediction about you, right? About you personally. And you go and test it, and it turns out to be right. And I think we'll be seeing more of those surprises as time goes forward, right? I think, in a sense, companies like Facebook or Google could be doing this much more now. They could be surfacing information about you that's surprisingly accurate. I think part of what holds designers of these systems back, just to speculate, is that it's not clear we all want to hear what these systems have to say about us. Right? Do you really want the system reminding you that you've lost touch with this whole circle of friends and you really ought to reconnect them? Or that, you know, your efficiency tends to drop really precipitously after 11 p.m. and you might as well just go to bed? Or, right? Are these things we want to know? Because it's certainly there in the data. Right? It would be easy to build those kinds of applications now. So I think that's another direction where this is all headed. It really branches out in many directions from here. But what I want to do is just wrap up with sort of one final thought. Actually, one sort of conclusion I often like to sort of wrap up with is to go back to some of the op-eds that people wrote in the early days of social networking, the early days of MySpace and Friendster and so forth, where people really began to feel concerned about what all this was doing. There was this quote from the Toronto Globe and Mail 5 years ago, summer of 2006, which sort of encapsulated some of the unease about this. This is sort of a useful thought for right after dinner. MySpace is doubly awkward because it makes public what should be private. It doesn't just create social networks, it anatomizes them, spreads them out like a digestive tract on the autopsy table. You can see what's connected to what, who's connected to whom, right? Sort of a grisly image, evoking a sense of what things were like maybe a few hundred years ago when people first began taking scalpels to cadavers to actually learn about what human anatomy looked like. And other people turned away repulsed, going, don't show me that. I don't want to know what's inside a human body. Right? It was somehow the familiar had become shockingly unfamiliar through our sudden looking at it in a new way. And that's, in a sense, what's happening with social networks and social processes. Right? This is the air we breathe. This is the world we live in. Social networks have been with us for tens of thousands of years, ever since human beings lived in social groups. Yet it's only now that we're starting to learn things that we never really were able to see before. And we're designing things that are shaping social structure in new ways, ways that attempt to span geography, beat back against geography. And so there are a lot of questions here, right? Why social networks produce the outcomes they do, how our designs actually affect and feed back into that, and all of these questions around the massive data accumulating about each of us, right? Both the kind of risks of privacy and also the idea of just software that understands us and understands things about us that we don't even realize. Many, many interesting challenges going forward, an opportunity for deeper understanding, deeper designs, and I think the kind of scientific research going on at places like Cornell is going to play a crucial role in all of this as we go forward. Thanks very much. So should we, yeah, so people have to go. Feel free. I'm happy to take questions if people have questions. Yes? Yeah, no, it's an interesting question. Let me repeat the question. So the question was, when you look at fits to a model, say for how our links span geography, to what extent does that say a US-centric picture, right? So in the US, the pattern of movement, right? How far do you move when you go to college? How far do you go when you change jobs? That could look very different from in other countries where the movement patterns might be different and create different social structures and how they span geography. Yeah, so that's an interesting question. I should say that actually the most recent study of this was on the global, it was on at least whatever Facebook covers, right? So all the countries that Facebook is in, it was doing that in some aggregate sense. But this kind of comparative analysis is going to be very interesting. And actually, I think part of the point is going to be that this is sort of a lens through which to compare different countries, different cultures, also different organizations, right? So one can apply this inside companies and ask, how far do the patterns of communication span the organizational hierarchy? Because in a large organization, Cornell, a big company, there's also a kind of geography where you can communicate with people very far away in the organization or people very close in. And there's also been some comparative work trying to use these models to study that. So I think absolutely, as a comparative lens, it's going to be a very interesting thing. And we may not see the same answers everywhere. Yeah? Yeah. No, that's a good question also, right? So the issue here is, as I mentioned also on one of the slides, in your social network, there are strong links, close friends, very committed to helping you, and what sociologists call weak ties, right? Links to people you don't know very well, to an acquaintance maybe, someone not very committed to helping you. And it turns out the pattern of strong and weak ties in your life relates a lot to things like socioeconomic status and inequality in society, where people who are very poor tend to have these very clustered networks of strong ties. People who are more affluent often have these sort of broad spanning networks of weak ties. And right, so there's actually been a bunch of recent work actually using online media, in particular using cell phone networks and phone call patterns of people to relate that to their socioeconomic status. Some nice work that my colleague Michael Macy has been doing here at Cornell and other people at other institutions. And in brief, the idea is that when you look at how people found the jobs they have, right, this goes back to work of Mark Granovetter in the 1970s, often they learned about this job through a distant acquaintance, through a weak tie, right? This came out of work he did for his PhD thesis, where he would sit in people's homes and he'd ask them, how did you find your current job? And they'd say, you know, I learned about it through word of mouth. He'd say, from a friend. They'd say, no, from an acquaintance. And he noticed this rebuttal, no, from an acquaintance. So often he began to wonder, what is it about acquaintances that are so good at finding you jobs? Isn't it your close friends who are committed to helping you? But the point is that your close friends know the same things you do, right? So when you talk about some big life-changing thing where, you know, you found a job that you just hadn't, you know, had access to before, if you didn't know about it, chances are your close friend didn't know about it either, right? You probably learned about it through information that leaked in through some distant part of the network, right? And at the risk of backtracking through a bunch of these, right? So the question is, if this person's going to learn about a new opportunity, not that they would necessarily, you know, want to leave Facebook, of course, but as their employer, but, you know, it may come in through one of these weak ties, through some other part of the social world that just has access to other information. And so this idea that weak ties imply access to many diverse sources of information, imply access to a range of opportunities, whereas a cluster of strong ties means you sort of only have the opportunities you have now. And so, yeah, trying to understand how that all relates to socioeconomic outcomes, very interesting question. Yeah?
I had a question regarding the dynamic filtering that a lot of sites like Facebook and Google do, to filter it according to what they think you would like. And just feeding off what you said about the leaderboard, if they're providing you leaderboard of sites you would like, then that means you're going to click on those sites a lot more, and then you know, those would keep going on to the top, which means you are essentially, because of what they're predicting, you're essentially becoming that person more and more.
Yeah.
Right,
yeah, the filter bubble, which is this recent book that talks about some of the ideas, and Cass Sunstein, maybe eight years ago, wrote some nice articles about this also. This idea that as software gets personalized to you, it creates this inward spiral, right? So it suggests things to you, you click on them, and so it says, oh, you must really like that stuff, let me show you more of it. So you click on it, but it's the system feeding it to you, right? In the same way that when you go buy books on Amazon, right? You know, you're trying to learn about some topic, you buy something, and it says, oh, here are some other books that are exactly like this one, right? That won't challenge your point of view whatsoever. There's this sense that personalization creates this sort of all-enveloping barrier around you that makes it harder for you to get exposed to new ideas. Yeah, so I think this is actually one of the most intriguing and potentially high-leverage places for design, which is that as designers of these systems, it's really a lot under the system designer's control what you're going to see. And one problem, right, people have wondered, has this radical personalization contributed to the kind of polarization we see in political discourse, for example, right? And the argument goes roughly like this. Once upon a time, 30 years ago, if you were a voracious consumer of news media, you loved reading about political news, then, you know, there was sufficiently little of it that you ended up having to read a lot, read very broadly, and encounter stuff that disagreed with your point of view. But nowadays, through the abundance of political blogs that are online, the fragmentation of the news media, and personalization, you can be an avid, voracious consumer of political news and never leave your tiny little place on the political spectrum. And so when two different people with different political opinions come to meet and they both have followed current events extensively online, they may have almost no common ground to talk about it, right? Because they're really sort of almost living in these different realities. And so the challenge is, how do we, right, so serendipity actually has this value, right? We serendipitously encounter things that broaden our points of view. Now, this is not to say that we should throw away personalization, right? Lots of times when you're looking for something, it's good to have it suggest things that you might like. But the question is, where is the balance, right? And there is going to be a balancing act, right? So you blundering around online, reading stuff at random, written by random conspiracy theorists and so forth, that's not useful, right? Directing stuff toward you is good. But only directing things toward you can create this fragmentation and consequently polarization. And so there is this balancing act. And that's a great example where the design of our technology and the kind of social or political outcomes that might result are very delicately intertwined, and one really needs to think about them. Yeah. Yeah, that's an interesting question, right? So the question of, if you look at a developing country, how it progresses over time and how the internet picture there sort of fills out, right? Because we noticed that on this picture here, there was a lot of stuff just isn't reached by the internet. Very little there, right? Central Africa, very little. Now, there's a whole bunch of things conflated here. There is the penetration of technology, the penetration of the open internet, and then just people's choice to use Flickr, which is where this data came from, versus something else. So many things get wrapped up here. But it is going to be an interesting thing to look at how, as we look at a developing country across time, how the technological picture enriches where we see the technology developing, and also how that actually interacts with development, right? And there are going to be intriguing things in that in a lot of developing countries, they're completely bypassing earlier technological things, right? So you don't need to build landlines for phones, so you can bypass that stage of the history of the telephone completely, as many developing countries one's seeing doing. So, right, so I think these questions about how technology is going to get used in these developing countries, and actually my colleague Larry Bloom, for example, studies how this affects agricultural markets in East Africa, right? So agricultural markets in East Africa, you take the day's harvest and you proceed down this road, which is, you know, rutted and barely usable and dangerous, and go 10 miles to the market. And if you go to this market, the price they're offering to buy your crop for is something. If you had gone 10 miles the other way, it would have been something else, and you didn't know. But now you get to the crossroads, and you have a cell phone that's telling you what the prices are in each direction. That actually affects how trade happens in East Africa, right? So despite the fact that the transportation technology and the civil engineering of the infrastructure, that's all still has a long way to go. The fact that we now have this digital infrastructure on top of it means people have access to much more information and are making decisions differently. And one can tell a bunch of stories of that sort where the technology gets overlaid on top of the culture, and we see interesting things happen. Yeah. Yeah, right. So the question of the so-called Arab Spring, right? So the uprisings in Arab countries in the past few months. How does technology, cell phones, social media, and so forth play into that? That's actually, there's a bunch of research going on about that right now, looking at Twitter. And in fact, some of it at Cornell. So with Michael Macy, again, in sociology, Xiaomei Wu, a PhD student in information science, and a bunch of colleagues of ours in the government department, we've been looking at data from Twitter and actually from those parts of the world and how it was happening as the protests were happening. And a bunch of other groups are looking at this. The question is, and there's a controversy here, right? So on one side, people say, something like Twitter is only good for these weak ties, where you're not really willing to risk your life to do something, right, for sort of these very distant connections. Whereas to actually engage in something like a revolution where you might get arrested or killed, you need these strong ties. You need to trust this other person. The counter-argument is that one thing that something like Twitter is very good at is coordination, and kind of anonymous coordination, right? If you're planning a protest, Tuesday at noon in the city square, it better be that everyone, who knows about it really plans to show up, right? Because if 100,000 people show up, then the government will actually be seriously weakened. But if only 100 people show up, they're all just going to get arrested. And so one role that social media can play is as a coordination device, right? One reason that repressive governments work very hard to limit access to information is because they don't want you all knowing whether or not 100,000 people will all show up in the city square at the same time, right? They don't want that to happen, right? They fear freedom of assembly, freedom of the press, not just because of the information channels, but because it's a means of coordination. And Twitter and Facebook have been able to, in a sense, make an end run around that because they go through these other channels that maybe weren't being as closely monitored. So I think that's going to be the interesting question to look at, right? How do these work as a way of building the kinds of ties you need to trust other people when you engage in a dangerous movement? Maybe that's more questionable. How is it as a coordination device? Thus far, it seems to be actually quite potent in that way. So I think these things play different roles. Maybe we should do one more question. Yeah. Yeah, so that's true, right? So your point is that just as we can't study the things we don't have access to online, it can actually be that people who are not online don't get represented when Facebook decides what to tell you about, what parties are happening, what events are happening. And so it can actually, in a way, work to undercut the offline parts of your social life because you're not getting those in your newsfeed or whatever. Yeah, that's also an interesting question, which, obviously that, you can think of lots of people probably who went online because they felt they were being left out of something by being offline. And that's sort of part of that reasoning. On the other hand, we sort of don't want that to be this all-consuming thing that you all have to be in the same place. So I think that's going to be, it's going to be an interesting question. And the question of how do we have something that really represents all parts of your social experience, on the one hand, it's a good thing. It accurately represents your life. On the other hand, it does mean a sort of consolidation of all that information in one place. And that gives a huge amount of power to whoever holds that information. Right? And so that kind of tension, right, this aggregation that makes your experience online richer, more reflective of your real life, but which also means that whoever it is that runs that site, right, be it Google or Facebook or any of these companies, has access to all that rich representation of your real life all in one place. I think that's going to also be a very interesting kind of question going forward. Thanks again.